Hey, thank you. Thanks, Earl. And good morning, everyone. So we're going to talk for just a few minutes here. We'll move quickly through it on how we're seeing big data. A lot of hype around this term, big data. So we want to talk about how we're looking at it and trying to stay away from the hype, if we can. Not easy. So first talk about big data in general, not specific to HPC, and you're all familiar with this. You've heard it all over the place, the 4 V's of volume, velocity, variety, and value. And we use that too. These are those attributes kind of mapped, each of them onto a spectrum. For the remark I make here is for HPC exists kind of as an extreme case in each of these dimensions of volume, variety, velocity, and value. This is a global survey that IDC did. By the way, we have about more than 40 analysts at IDC who are tracking big data, and there are 6 lead analysts. I'm one of them because HPC is an odd duck. And so it's really important that that be represented. But this is a survey applying across all of big data, not just HPC. And nearly all of these attributes, which I'm not going to go through because there isn't time, apply as well to HPC. The biggest one, risk management. These are challenges that the responses had in the survey. And the biggest one there is you're seeing, which data is relevant. Kind of remember when we started this thing visiting with a company that was a pharmaceutical company, sort of pursuing advanced research in systems biology. And I asked the CIO there, I said, what keeps you up at night? What really makes you worried? And he said, every day we come to work and we decide what we're going to do that day, and every day we think, maybe we should be doing something completely different. So deciding what data is relevant is a big one. Not going to go through all this, but these are the areas that we've mapped out at IDC for big data coverage. Also not going to go through this too much, but you can see what it is. It's at the bottom, infrastructure, and then kind of ordering the data, performing operations on the data, and then getting the outcomes in terms of either decision support or other desired outcomes. Shortcomings. I could summarize this slide by saying that people can't do what they want to do with the tools that are available. That's basically what this all amounts to, and that we hear, and I'm sure you hear all the time. So turning to big data specifically that requires the use of HPC now, and we have the term high performance data analysis. We're not like terminological inventors. We don't really kind of get off on inventing new terms. Fewer terms are usually better, but we ran into an issue that required us to do this, which is turns out to be a convergence market in the sense that there are kind of 2 communities coming together here. The existing HPC community, and as Earl kind of implied, commercial folks who are moving up to HPC for the first time and not using the terminology of HPC. Although they're starting to now, they really didn't like it a few years ago. So high performance data analysis is the term that seems to be a compromise term that both sides are okay with. So what does it mean? It's a term that covers both data intensive modeling and simulation as it's been practiced forever in the original big data market, high performance computing, and also newer analytical methods that are being used by that community, our community, and also now, as I said, by commercial companies that are moving up for the first time to HPC. The drivers you're familiar with. Lots more data to ingest and deal with because the data sources are putting out more data. And then the tools, the computers are also a lot more powerful, so the outputs are also much bigger in data volume, driven by a need for more realism, and especially for time constraints. And then one thing that really characterizes high performance data analysis, whether it's being practiced by traditional HPC folks or commercial folks, is the algorithmic complexity. the algorithmic complexity that is not typical for business, traditional business transaction processing, CRM, ERP, and so forth. So it really amounts to the need to pose more intelligent questions. That's what HPC is for. And the other thing that's driving people, for example, PayPal, as you'll hear, to HPC is the need to do things they've already been doing, but to do them in real time. This we've heard, energy consumption for data movement is something that people pay a lot of attention to, including on the commercial side, and the two available strategies for dealing with that, the main ones anyway, are to faster fabrics, accelerate the data movement, or reduce the data movement through things like in-memory compute and other strategies there. And the big dividing wall here is a dividing wall that's existed in HPC anyway for a long time, but it applies also to high-performance data analysis. As far as the architectural requirements, it kind of divides into work that is partitionable and work that's non-partitionable. Most of the work is going to be on that left side and be done on clusters, in technical computing clusters. But some of it is not, and we believe that the highest value kinds of work that are coming up, the most economically important and scientifically important, is going to be on the right side of the slide there, as we kind of transition from search kinds of functions where the answer already exists somewhere, you just have to find it. I mean, that's what happened with IBM Watson. If the answers weren't in the database, Watson wasn't going to find them. To the era of discovery, which Watson is also participating heavily in, as are things like, Craze, Eureka, and SGI and others. So this is a server forecast, and the way that we characterize machines, Earl showed a slide earlier that showed, bio and defense and so forth. The way we characterize machines is the primary rationale for their use, because in HPC, a lot of times, systems are used for more than one thing. So if it's more than 50% of the cycles, it gets put into that bucket. And for high performance data analysis, it's got to be more than 50% of the use has to be for that purpose. What you see on the top row there is some of what Earl showed, which is all HPC servers. The middle row is the portion of that belongs to high performance data analysis. And as you can see, on the last row there, the percentages are still going to be in single digits after a few years here, but the growth rate is very quick for that. And we've done forecasts now, just not for the server piece, but also for the storage piece of this market and so forth. Okay, so that's that. The more important part is, as Earl said, use cases. What are people actually buying and what are they using it for? Major use cases are emerging already. And what we like to look for is not one-offs, or in some cases, five-offs or whatever, but which use cases are repetitive enough that they're starting to resolve into pursuable markets, so forth. And this is some of what we see here. Fraud and error detection is a very big one. And there are allied applications there like identity resolution and so forth that are important. National security, lots and lots coming up in healthcare, which we'll talk a bit more about. And then it's also extending to business functions having to do with customer relationships and social networks and so forth. So here's a case in point, PayPal. PayPal is a company, it's part of eBay, which is a $14 billion company. PayPal, among its responsibilities, is detecting fraud across all of eBay, Skype, and another property they have called StubHub. They were using Hadoop, Cassandra, kind of the usual stuff to try to detect fraud, but their volumes are so large that it took them 2 weeks. Well, it's too late. The train left the station. All the fraud hit the credit cards by that point, so they just were looking at it without being able to do anything about it. They had a management meeting. In the management meeting, they didn't include IT because it wasn't an IT problem in their view, it was a business problem that they had. Big difference. However, there happened to be somebody in in that meeting who had some background in HPC and said, folks, this problem's been solved. It hasn't been solved in our part of the market, but it's been solved by the HPC community. And we promise you, this one's been solved. So they did a demo project, and then they started buying. And what happened was that what they were looking for, of course, is what I say in yellow there are patterns, of, unknown patterns in fraud in the data and so forth. And this gives you an idea of their volumes, big volumes. This is kind of where they went. I mean, they bought real HPC stuff. And this was the first year result for this that we estimate, and the estimates are pretty close, that they saved in the first year about $710 million with HPC. 2 weeks ago, I had a follow-up call with Jim Barisi, who's the CTO of PayPal, and I said, what are you doing with this success? And he said, well, there are two more. First of all, we're hiring HPC people as fast as we can find them. And the second thing is that we're going to apply this now to 2 more areas and really expand HPC use within the company. One of those is further personalization of the consumer experience. If you're walking through a mall and you pass like a Jamba Juice or one of those stands and they know that you kind of like something, they're going to send a coupon out to you right then and there to your cell phone or mobile device while you're doing that. A little scary in a way for privacy, but that's one of the things. And then the other things they're using HPC for is to manage their large systems, the whole thing. They need that. GEICO, they represent a different category, and we have lots of examples in this category too of commercial firms coming up to HPC for the first time. And these folks, GEICO lives and dies on insurance quotes, big insurance company, and if the quotes are too high, they don't get the business. If the quotes are too low, they go out of business. So what they needed to do was they use HPC now. They bought a pretty good sized cluster, and every Friday, Saturday, and Sunday for 60 hours of clock time, it recalculates for every insurance product they have a quote for every adult American and household. And so Monday morning they have a new quote, so forth. And but the interesting thing is it's not really exactly real time. They only need to do it once a week, but it's not something they see moving to a workstation anytime soon. This is the US Postal Service. When we did the slide, we weren't allowed to say, but it's US Postal Service fraud detection for their packages. They operate worldwide. This is a different one. This is a university in the US that's an online university with about 280,000 students enrolled. Pretty big enrollment. And to get that kind of a yield of students, they have to touch a lot of millions of candidates, and then they have to keep them, which is more difficult. So lots of communication has to happen. They moved to HPC to essentially create a virtual admissions office and retention office, and career office too, because they're using it for that. So they're expanding their use of HPC. SCHRÖDINGER, German pharmaceutical company, in their case, that's a very competitive industry, as you know. And what they did is they increased the resolution of their algorithm for finding good promising compounds for drugs tenfold. And then they decided, let's apply it to a full run, which is the $21 million candidates. And they went to the cloud with the help of cycle computing. They went to the cloud. They grabbed 51,000 cores of Amazon for a 3-hour run. Cost them about $14,000 to do that. And it was so successful that they've now made it a practice. Only the price has dropped threefold since then. One of the patterns that we're seeing with commercial companies that go straight to the cloud, however, if they're in the part of the market where all the work isn't partitionable, is after about a year and a half, 2 years, something like that, they go, we really need to buy some stuff and start an HPC data center and have both. So that's the pattern that we're seeing. Anyway, that's the architecture, and these slides are available to anybody who signed up here that these folks are using. They have a little bit of on-premise and then out to the cloud. This one's important and across the world. One of the things that the healthcare industry is trying to do over a period of years is transition from the way that it operates now, which is it's really based on procedures. Everything is driven by procedures, tests. They get paid for tests, surgeries, examinations, and so forth, to one where it's based on outcomes. This sort of been a dream in that industry for about 20 years, and outcomes-based methodology is extremely different, and it's very personal, and it's extremely data intensive. It's going to take them years to get there. An example is, let's say, I have an accident where my hand gets squashed, something like that. For me, Steve Conway, a pretty good outcome is if I can regain most of the use of my hand. But if I'm a concert violinist, it's a little bit different story. That's not a good outcome. I need a better outcome than that, or else I'm not going to be able, I'm going to have to change what I do for a living. So it's very, very personal. What they want to be able to do over the years, and that includes national health plans in Europe as well, is to get to a point where you go into the office, they kind of have your history, maybe also your genomic history. They catch your symptomology by examining you, and then instead of relying for kind of decision support on what they know about some medical studies that usually have not too many people in them, they run your data against archived records that might be 10 million or more records, and then it spits out a curve, an efficacy curve, of treatment possibilities for you that the provider, physician or other provider, isn't required to follow, but it's a decision support tool. That's where they want to get to over the years. And so one of the biggest healthcare companies that operates both in the US and in Europe, United Health Group, it's about a $120 billion company, is investing an initial $500 million to build a center next to MIT in Cambridge, Mass. And it's going to be all pre-competitive research. Their arch rivals, their worst competitors, are allowed to come there and do research because they figure they need to push the state of the art, and they're willing to take that risk. The first to sign up is Mayo Clinic for that, and it'll take them years, but that's what they're trying to do.
You may want to change the K to an M.
What's that?
500K.
Oh,
Yeah.
just wanted to see if everyone was awake.
Yeah, this 500 million is the right number.
Yeah, I'm sorry, it should be 500 million there. And then this is sort of an example of something very different that we're seeing, and this is a company, one of multiple companies that are working. It's really interesting that are kind of like one-trick dogs, as you say. They kind of do one thing, but they do it really well. And this company, little company MCN, is working with everyone from intelligence communities to retail people like Walmart. All right. And in this case, they were working on behalf of the Atlanta Police Department because there's a lot of gang activity there. But they also work with the intelligence community and successfully caught an Al-Qaeda cell that wouldn't otherwise have been caught. And here they just were able to catch a merger of two major gangs that allowed the police to prepare for that. So in summary here, we've got a convergence market where HPC is the lead, and commercial companies are starting to come into it pretty heavily. And we're starting to see what we weren't able to see a few years ago, that the really economically important use cases are starting to become apparent now. Requires different kinds of architectures, and we're trying to be conservative with it. This, by the way, talk a little bit later about HPC, our HPC user forum. By the way, we have some people on our steering committee for our HPC user forum, which some of you are familiar with. Rupak Biswas from NASA is here, Steve Finn, Cherokee Information Services. I think Marie-Christine Solly helped us a lot in some earlier years. And these are just some of the big data talks that we've had around the world. It's kind of a short list, and it's all over the place, from commercial all the way into the sciences and humanities as well.